This video is on functions, yay or nay. We're going to be reviewing interval notation. We're going to be taking our inequalities and writing them in interval notation so that we can focus on domain and range, because that goes along with our x and y values. So we're going to be rewriting these into interval notation. Our first one is x is greater than 4. Now, since it is saying greater than 4, that means it will be going towards the right. So the numbers that are greater than 4, the 5, the 6, 7, this will go to the right-hand side. That means that it will go towards the positive infinity. So our interval notation, our starting value is that 4, because we're going to go to everything towards the right. So our smallest number is 4, and then it will go towards that positive infinity. With interval notation, we have brackets. The 4 is not included in the equality, so this is not a closed bracket, it will need to be an open bracket. The positive infinity is never reached, so this will be an open bracket as well. Since we're dealing with x's, this is going to be an x is an element of from 4 to positive infinity. On this next example, it says x is less than or equal to -2. Since it is less than, this will be going towards the left-hand side of the x-axis, which means it will go towards the negative infinity. With that, the smallest value between -2 and negative infinity is negative infinity. The highest value will be that -2. The negative infinity is never reached, so that will be an open bracket. The -2 is included in that equality, so we can close that bracket. And again, we're dealing with the x's, so this is going to be an x is an element of negative infinity to -2. This next example has a number line. Now, the number line has part of it shaded and part of it not. This gap in between here makes it a discontinuous graph. So this actually is a new thing for domain and range. So let's look at the different parts of this. We have an arrow that's pointing to the left. So that means that it will have a negative infinity because it does have an arrow. Then we come to this value, which we stop at because it has a break the next part. So this is a stopping point. We have a break between this 7 and that 11. But then we start back up at that 11. So I can call that's a starting/stopping point. So I'm just going to put stop. But then we have an arrow, a solid part over here, an arrow pointing to the right, and that will go towards the positive infinity. Now we just put this all together. We're going to be dealing with, this is going to be an x is an element of. So to write this, we have our negative infinity, which has that open bracket. We have solid aspects here, so I'm going to put a comma. But we do stop here. We stop at that 7. So I'm going to put the 7 here. That is an open circle, so I'm going to have an open bracket. That means I'm not including the 7. But then we have a break. Now this is, again, this is a discontinuous graph. We need to include the entire graph. We need to include every part of the interval notation. So we need to unite these two parts of the graph. We use what's called the union. This is an or. Really means or. We have the values on this side of the graph, or we have the values on this side of the graph, on the right-hand side. We just do not have the values in between them. So we're uniting these two parts of the graph with the symbol for union. The intervals will actually start back up at that 11, because that's where that solid part starts back up. And it is a solid point, so this will be a closed bracket. There's more solid. And then it will actually reach that positive infinity because that gets to that arrow. So I'm going to put positive infinity. Again, positive infinity is never actually reached, so we're going to put that open bracket. That is how we write it in interval notation with a discontinuous graph. We use a union to say what all part of the graph is actually used. The only part of the graph that's not used is everything from that 7, so including the 7, up to, but not including that 11. That's not what is being used. Everything that is used is all the way from negative infinity to the 7, but not including the 7, and then from that 11 all the way up to positive infinity. So let's look at this table where we're going to fill in this information. We'll be given set notation, interval notation, or the graph on a number line, and we will then fill in the rest of it. For set notation, on this one we have x's. We have 2 values. That means that in interval notation, we would have 2 endpoints. So on a graph on a number line, we're going to have 2 endpoints. We're going to have everything between them. Interval notation from set notation, you have to write it in that same order. So it goes from -3, and it includes all the way up to that 8. The -3 does not have that equality part to it, so it will be an open bracket. The 8 does have the equality, so it will be a closed bracket. If we're going to graph this on the number line, I'm going to draw out a line. I'm just going to put our 2 numbers on it. We don't have to put every single number there. We just need that -3 and the 8. So I'm going to put the -3 here. I'm going to put the 8 here. The -3 is going to be an open circle, and the 8 will be a closed circle. It's because of the brackets. That means an open bracket, so it's an open circle. Closed bracket is a closed circle. And we want all of the values in between this, because it's starting at -3, but it's stopping at the 8. So if it starts at the -3, it keeps going until it stops at that 8. So this is how we would see the graph on a number line. The next example, we're given an interval notation. Now, this interval notation has a union in it. What that means is OR. We have part of a graph, then we have another part of the graph. So when we write our set notation, let's do that one first. I'm going to have my squiggle bracket, x such that. So I focus on this first part first. This has one endpoint, so I have x, and then I'll have the 4. Now I need my inequality. It is going towards negative infinity, that's less than the 4, and it is a solid bracket, so that would be a less than or equal to that 4. The union means OR, so I'm going to put the word OR here. Then I'm going to do my next part. So again, I'm going to use the x because I only have one number, one endpoint. And we want the 9. It's going to positive infinity, that means that it's going to have the numbers that are greater than 9. We want numbers x is greater than 9, but it will not have the equality part because this is an open bracket. So we can end this. That would be our set notation. The OR is what's uniting the 2 different aspects. When we do our number line, we're going to make sure we see that same thing. We still only have 2 numbers. I'm going to put that 4. I'm going to put a 9. The 4 is closed. I will darken that 4, close that 4, but the 9 is open. The union means that there's a gap between it, there's a break. So this will be, again, this is a discontinuous graph. I want from 4, and I'm going to go towards the negative infinity, which means I'm going to go towards the left. I'm going to shade that. I'm going to put an arrow there because I know I can't keep going forever, but I can't keep drawing that forever, so the arrow tells me I'm going forever. Then we start at the 9, and we want to go towards the positive infinities, which is to the right. I'm going to do the same thing, and when I get towards the end, I'm going to put an arrow there saying it's going to keep going. But there is a gap between the 4 and the 9. The union is what is uniting the 2 parts on the graph. That is our graph on a number line. This next example, we're given the graph on the number line. we want to put it in set and interval notation. We can go ahead and put it in interval notation. We have our graph has one arrow and one endpoint. That means there will be an infinity and one number. The number is 3, and it's going towards the left, so that means that will be a negative infinity. We have a negative infinity as your smallest value, and then the positive 3 is your largest. Negative infinity is never reached, so it's an open bracket. And the 3 on the number line is open, so this will be an open bracket as well. For our set notation, squiggle x such that. One number means I'm going to have my one inequality, so I'll have my x and I'll have my 3. My inequality wants to go towards the negative infinity, so that's a less than. It is not closed at 3, so I do not have the equality part on our set notation. And that is our set notation. The last set notation here, we have x such that x is equal to 7. This is not an equality in inequality. This is equal. We do not have it going left. We do not have it going right. This is just 7. Not all numbers up to 7 or after 7, but just 7. So for interval notation, I put my 7, but I have nothing for it to go towards. That means I'm only staying at 7. It is equal, so it's a closed bracket, and it's stopping at 7 again, so I just close the bracket. It's only one value. On the number line, you would still need to put this on the number line. There's just no shading because it's a one value. So I'm going to have one number of 7, and it's a closed circle at 7 because it is equal to 7. One number would only have one number inside your brackets as well. So this is how to rewrite set notation into interval notation and vice versa, and also how to use it on a graph on a number line, and how to use your graph to be able to write your set and interval notation.